Hi, I Aziz welcome you to CoedMaster, and in this video I am going to talk about this problem. So let's get started. Alright, let's see this problem. In this problem we are given an array and we have to find maximum subarray sum. It means we have to find a subarray whose sum is maximum, and then we have to simply print the sum of that array. So before we move ahead, let's talk about what is meant by subarray. So let's say we have an array like this 1, 2, 3, and these are all the subarrays made up of elements present in the given array. So these are 1, 2, 3, 1 and 2, 2 and 3, and 1, 2, 3. So we can say that an array is said to be a subarray if the elements of that array is the contiguous elements picked from the given array, right? So you can see that here 1 and 2 are the contiguous elements present in the given array. Same with 2 and 3 and same with 1, 2, 3. So now let's understand this problem with few examples. So let's say we have an array like this 2, -3, 6, -5, 4 and 2. The subarray of this array that gives maximum sum is 6, -5, 4 and 2. And the sum of this subarray is 7. So the output of this input is 7. If you consider any other subarray other than this, you will never get maximum sum greater than 7. Let's see the next example. Here the array is given as 1, 2, 3, 4. And here the maximum subarray sum is 10. And this is the sum of all the elements present in the array. As in this array, all the numbers are arranged in increasing order and all are positive number. That is why out of all the subarrays having all the elements has the maximum sum. Moving on to next example. Here you can see all the elements are negative, and when elements are negative we can get the maximum subarray sum is -1 because the 1 in itself is a subarray. And if we consider any other subarray other than -1, we get a sum that is less than -1 because -1 and -2 is going to be -3, that is less than 1. -1 and -4 is going to be -5, that is also less than -1. So I hope now you understand this problem really well. So let's pause this video and think about an algorithm to solve this problem. Alright, by now I hope you would have written at least basic program to solve this problem. So let's talk about the brute force approach first. So the idea of brute force approach is pretty simple. We have to simply traverse the array from 0 to n-1. And for all the elements present in the array, we have to find all the possible subarrays beginning with the current element. And then we calculate the sum of all the elements of that subarray. And while calculating sum, we are going to store maximum sum we have found so far in the variable maximum so far. And we are going to repeat this process for all the elements present in the array. So this is the basic idea. Now let's see how we are going to do it. So we have an array like this 2, -3, 6, -5, 4 and 2. So first we consider the first element and find all these subarrays beginning with this element, and these are the all subarrays beginning with 2. The sum of elements of all the subarrays are 2, -1, 5, 0, 4, 6. So as we are traversing, we simply update the maximum so far variable. So in first iteration we have 2, that is greater than maximum so far, so we update the maximum so far to 2. Then we get -1, that is smaller than maximum so far, we leave it as it is. Then we get 5, that is greater than maximum so far, so we update it like this. Then we get 0, that is smaller than maximum so far. Then we get 4, that is also smaller. Then we get 6, so we update the maximum so far to 6. So maximum so far we have found is 6. Now let's move on to next element, that is -3. So now we consider all these subarrays beginning with -3. So we get -3, then 3, then -2, then 2 and then 4. So you can see out of all the sum there is no sum that is greater than maximum so far, so we keep the maximum so far as it is. Now consider the next element 6 and find all the subarrays beginning with 6. We get 6, 1, 5 and 7, and you can see that now we get one number that is greater than maximum so far, so we update 6 to 7. So this is how we get our maximum so far as 7. And if you consider -5, 4 and 2, you will never get number that is greater than 7. So this is how this approach is going to work. Now let's see the implementation of this basic approach. Here we have a function maximum subarray sum. This function is taking arrays input. Okay. In the first statement we are getting the length of array, and in next statement we are initializing maximum so far variable to 0, and our loop begins. We are running loop from 0 to less than n. Inside this loop, in first statement we are initializing variable sum is equal to 0 to store all the sum of the elements of the subarray, and then we are running a loop from j equal to I less than equal to n. Inside this loop we are adding all the elements into this sum variable one by one, and along with it we are also finding the maximum of maximum so far and sum. If we found that the sum is greater than maximum so far, then we simply update maximum so far to sum, and after the outer loop we are simply returning the maximum so far value. So let's quickly dry run this code and see how it works. So we have this array 2, -3, 6, -5, 4, 2. Maximum so far is 0. We run this program and our loop begins. The value of I in the first iteration is 0, and element present at 0 index is 2. Okay. Then we run inner loop. Before running inner loop we initialize sum to 0 and j is equal to I, that is equal to 0. Okay. In next line we do 0 plus 2 means previous sum plus array of j, that is 2. So 0 plus 2 is equal to 2. We get our new maximum so far, so we update maximum so far to 2. Next we do 2 minus 3. 2 minus 3 is equal to -1, that is smaller than maximum so far, so we keep it as it is. Then we do 2 minus 3 plus 6, we get 5, and again this is maximum then maximum so far, so we update the maximum so far to 5. Then again we do 5 minus 5, that is 0, so we do not have to do anything. Then we do 0 plus 4, that is 4, it is also less than maximum so far. Then we do 4 plus 2, that is 6, and 6 is greater than maximum so far, so we update the maximum so far to 6. Then we move on to the next iteration of the outer loop. So this time the element we have to consider is -3. So now we have to find all these subarrays beginning with -3. So the value of j is 1 and value of sum is 0. So 0 plus -3 is equal to -3, that is smaller than MSF. Then -3 plus 6, that is equal to 3, it is also smaller than maximum so far. Then 3 minus 5 is -2, that is also less than maximum so far. Then -2 plus 4 is equal to, this is also less than maximum so far, and so on and so forth. So in this iteration we have not found any number that is greater than maximum so far, so we keep maximum so far as it is. Moving to next iteration of the outer loop, now the value of I becomes 2, and this time we have to find all the subarrays beginning with number 6, because 6 is present at index 2. So we initialize the sum to 0, I is equal to j is equal to 2, maximum so far is 6. So we consider 0 plus 6 is 6, then 6 plus -5 is 1, then 1 plus 4 is 5, and 4 plus 2 is 7. So now we found the number that is greater than maximum so far. So we update our maximum so far to 6. And similarly this loop continues for other elements as well. 4, 5. For index 4 and for index 5. But we will never going to get a number that is maximum than 7. So the output of this input is going to be 7. This is the maximum sum of subarrays present in this array. So far so clear. Now talking about the time complexity, in this function we are running nested loops. Outer loop is running n times and inner loop is also running n times. So we can say that the time complexity of this function is big of n square. Now talking about the space complexity, as we are not using any extra space, so the space complexity comes out to be theta of 1. So overall, to solve this problem, this approach took big of n square time and theta of 1 constant space to solve this problem. But the question we ask ourselves is, can we do it better? Can we reduce the iterations? Can we solve it in big of n time complexity? Do we have any other approach to solve this problem? So please ask all of these questions to yourself and observe the given array and think about a solution that can solve this problem in big of n time complexity. Alright, so before we move on to efficient solution, I would like to introduce Kadane's algorithm. because in efficient approach, we are going to use Kadane algorithm to solve this problem in big of n time complexity. So here is a brief introduction to the history of Kadane algorithm. In 1977, this problem was first proposed by Ulf Grenander. He was a professor of applied mathematics. He was looking for rectangular subarray sum in two-dimensional array to solve some problem related to digital images. Back then, he wrote a brute force approach to solve this problem, and this approach took big of n to the power 6 time to solve this problem. Then he proposed one-dimensional problem to gain insights of digitized images. And to solve this one-dimensional problem, he derived an algorithm that solves one-dimension problem in big of n square time. When Michael Chemos, an American mathematician, heard about this problem, he overnight devised an algorithm using divide and conquer technique that solved this problem in big of n log n time. So one day Mr. Michael visited Carnegie Mellon University and he was describing about this algorithm and its history. Eventually, Mr. J. Kadane was also present there. And when he first heard about this problem, he immediately wrote an algorithm that can solve this problem in big of n time. And that algorithm is the fastest so far. So this is all about the history of Kadane algorithm. And this algorithm is named after J. Kadane. So far so clear. Now let's talk about the intuition of the J. Kadane while he was working on this problem. So let's say we have an array like this 1, -2, 3 and 4. In normal approach, what we are doing, we are considering each element and we are finding all the subarrays beginning with this element. Okay, so here is 1, then 1 plus -2, 1 plus -2 plus 3, 1 plus -2 plus 3 plus 4, and this is how we are getting all the subarrays. And out of all the subarrays, the maximum sum of subarray is 7. And to solve this problem, we are using 10 iteration. Okay, so what Mr. Kadane has done, so Mr. Kadane took the different approach, and according to his approach, instead of finding all the subarrays beginning with the element, he find all the elements ending with the element. So for example, if we consider 1, then all the subarrays ending with this element is 1. Then we move on to -2, and all the subarrays ending with this element is -2, 1 plus -2. Okay, so on and so forth. And if we follow Kadane approach instead of normal approach, we are getting the same results. You can see that all the subarrays we got so far is exactly same as all the subarray we got before. And the maximum sum also is same as before. And here also we are taking 10 iterations to find all the subarrays ending with this element. Okay. But using the Kadane algorithm, we can drastically reduce the number of iterations we are using here. Let me explain you how. So first, let's consider the element 1. So all the subarrays ending with this element is only 1, because 1 in itself is a subarray. So the maximum sum of this is 1. Moving to next element, -2. Now all the subarrays ending with this element is -2 itself or -2 and 1. And maximum of both the subarray is -1. So we write -1 here. Now moving on to next element, that is 3. Now all the subarrays ending with this element is 3, 3 and -2, 3, -2 and 1. So we have total 4 choices. And out of 4 choices, the maximum subarray sum is 3. Okay. Moving to next element, 4. Now if we consider 4, again we have more choices. Either we go with 4 or 4 with 3, 4 with 3 and -2 and 4, 3, -2 and 1. So we have total 4 choices. Out of 4 choices, the maximum subarray sum is 4 plus 3, that is 7. Okay, so out of all the maximum subarray sum, 7 is the maximum subarray sum. But now the question over here is how to calculate all these subarray sum. Do we have to really go to backside and find all the subarray ending with this element or what? So here, to your surprise, that we can find maximum ending with element with this 2 expression. So here you are taking maximum of maximum subarray sum ending with the previous element plus the current element or the current element itself. It means the first expression is saying either you extend the previous subarray or create a new subarray ending with this element. Okay. So let's go back and see this example once again. So here the maximum sub of 1 is 1 because we do not have any previous element. Okay. Moving on to next element -2. Now we can extend the subarray or we can start the new subarray ending with this element. So we have two options here, and out of two options the maximum subarray sum is -1. Moving to next number, that is 3. Now here again we have two options. Either we extend the previous subarray or we start the new subarray ending with this element. So 3 minus 1 is 2 and sum of 3 is 3. So the maximum is 3, so we keep 3 as it is. Moving to next element 4. Now here also we have two options. Either we extend the previous subarray, that is 3 plus 4, or create a new subarray ending with this element. So 4 plus 3 is 7 and the sum of 4 is 4. So the maximum of both of the option is 7. Okay. So this is how we find maximum subarray sum, that is comes out to be 7. And to calculate maximum subarray sum of all the elements, we are using this expression, that finding the maximum subarray sum of previous element plus the current element or current element and take the maximum of both. So this is how Kadane algorithm works, and now you can see that we do not have to go and find all these subarray. We can simply cancel out all the iterations and we can reduce the iteration drastically. Okay, so this is how Kadane algorithm works. I hope you got it. So the idea of Kadane algorithm is simple. We have to traverse an array from left to right. Then for each element we have two options. Either we extend the previous subarray or start the new subarray ending with this element. And while traversing all the elements, we have to keep track of maximum sum we have found so far. So now let's quickly see the implementation of this approach. Here we have a function maximum subarray sum. In first statement we are getting the length of the array, and in second and third statement we are initializing maximum so far to first element, and maximum ending is also the first element. The reason is pretty simple, because the 1 in itself is a subarray. So we are storing 1 as the maximum so far, and the maximum ending we have found so far is also 1. So after initializing maximum so far and maximum ending, we are running a loop from I equal to 1 till less than n. Inside this loop we are finding maximum of subarray ending with the previous element plus current element or the current element. Okay, and the maximum is going to be the maximum ending we have seen so far. And after this step we are comparing the maximum so far with the maximum ending. If we found maximum ending that is greater than maximum so far, then we are immediately updating maximum so far to maximum ending. And in the last we are simply returning the value of maximum so far. So now let's dive into this code and see how it works. So here we have array like this 1 minus 2 3 4. We start the loop from index 1. Maximum so far is 1 and maximum ending is also 1. Okay, our loop begins. In first iteration the value of I is 1. So here we have two options. Either we extend the previous subarray or start the new subarray. Okay, so the maximum of both is -1. So we update the maximum ending is -1, but it is not greater than maximum so far, so we keep the maximum so far as it is. In next iteration the value of I becomes 2. We again have option, either we extend the previous array or start the new subarray from this element. So if we do 3 minus 1 we get 2 and 3 is the maximum. So we start the new subarray ending with this element. Okay, so we update the maximum so far is 3 and maximum ending is also 3. In next iteration the value of I becomes 3. Here also we have two options. Either we extend the previous subarray or start the new subarray ending with this element. So 4 plus 3 is 7, and if we start new subarray then the sum of this subarray is 4. And the maximum of both is 7. So we update the maximum so far to 7 and maximum ending is 7. So basically the output of this input comes out to be 7. Okay, so far so clear. Now talking about the time complexity of this function, as we are running loop n times, so the time complexity of this function comes out to be theta of n, and the space complexity comes out to be theta of 1, because we are not using any extra space other than the input array and the few variables. So basically To solve this problem, this approach took theta of n time and theta of 1 constant space to solve this problem. So before we end this video, let's have a quick recap of what we have learned so far. So we are given an array and our task was to find the maximum subarray sum. It means we have to find the subarray that is having the maximum sum. To solve this problem, we saw the brute force approach, and in this approach the time complexity came out to be big of n square. After brute force approach, we saw the efficient approach, and in this approach we have used Kadane's algorithm, and using this approach the time complexity came out to be theta of n. So I hope now you have a solid idea of how to find maximum subarray sum in any given array. So this is it for this video. Thanks for watching. See you in the next video.